Good evening. So in today's class, we'll be talking about a very crucial concept of class 10, class 11, class 12 periodic table chapter, which is locating an element in the periodic table. So in this particular video, we'll be just dealing with the class 10th way of dealing with the location of elements in the periodic table, where we are not specifying the block. In my next video, I'll be dealing with locating by specifying block, which is for class 11 and class 12. So when I talk about the modern periodic table, which was made by Henry Moseley, it comprises of two kinds of divisions, which are called groups and periods. And the third kind of division is called block, which is a collection of groups. So block is dealt with in class 11, so I'll be dealing with that in my separate video. So groups and periods, groups are the vertical columns and periods are the horizontal rows. Okay, there are 18 groups and 7 periods in the modern periodic table. That means 18 vertical columns and 7 horizontal rows. Now talking about locating an element, if I am given any element, firstly I need to write its electronic configuration for locating it in the periodic table. So suppose I have the element called as magnesium. Magnesium is denoted by this magnesium, and its atomic number, which is called Z, is 12. So writing the electronic configuration now, if I write it as K, L and M shells, it will be 2, 8, 2. This is the atomic electronic configuration. Now from this we will be able to locate the element. The number of shells, that is number of KLM, will give you the period. How many shells I have used here? I have used the K shell 1, I have used the L shell 2, I have used the M shell 3. So that means how many shells do I have? 3 shells. So what is the period? 3. Third period. Now for the group. For the group, I will locate the valence electrons. Valence electron means the last shell electrons. Last shell is M. So what is the number of valence electrons here? 2. These are the number of valence electrons. For valence electrons, if they are 1 or 2, the group number is 1 or 2. So the group is 2. But if the valence electron is 3 to 8, 3, 4, 5, 6, 7 or 8, I will add 10 to it for the group. So 3 becomes 13, 4 becomes 14, 5 becomes 15, 8 becomes 18. But for 1 and 2, it will be direct. So this is group 2. So what is the location of magnesium? Second group, third period. So if I go down like this, suppose this is my periodic table, one block of it. What is the period? It has 3. This is period 1, period 2, period 3. This is group 1, group 2. So second group, that means here, third period here. This will be magnesium. This shaded box will be the magnesium. I take another example with which it will be clearer. We take the element chlorine. Chlorine has the atomic number of 17. So Z for chlorine is 17. So if I write the electronic configuration, 2, 8, 7. Period is very clear. There are 3 shells. Okay. So we can easily see from this that there are 3 shells. 1, 2, 3. So period becomes 3. For group number, I will see the valence electron. Last shell. In the last shell, these are the valence electrons. How many there are? 7. For 1 and 2, we directly write the group number as 1 and 2. From 3 to 8, we add 10. 7 is from 3 to 8. So I add 10, which becomes 17 as the group number. Okay. So suppose in the periodic table, I have here, somewhere here, this is group number 17. Suppose this is group number 17 and I have period number 3. This will be chlorine. And here are the other groups. Clear? One last example for this video will be the most important element, oxygen. Oxygen. Now oxygen has the atomic number Z as 8. That means what is the electronic configuration KL? 2 and 6. How many shells? 1, 2. So what is the period? 2. Now for group number, I will see the valence electrons. It is 6. 6 means it is from 3 to 8, so I have to add 10 for the group. That means it is going to be group number is 6 plus 10, which is equal to 16. So if I have, suppose this is group number 16, it will be adjacent to 17. So this is group number 16, and I have to take period number 2. This will be oxygen. Fine. So this is how we do the location in the modern periodic table at the class 10 level. So for period, we will see the shell after writing the electronic configuration, and for the group, we will see the valence electron, that is the electrons in the last shell. If they are 1 and 2, group number is 1 and 2. If they are ranging from 3 to 8, that means group number is adding 10 to them. 3 is 13, 4 is 14. Clear? So that's all for today. Thank you, take care, and please like, share and subscribe.